Okay, here we are, 5-4, day 2. Continuing on with antiderivative or integral, and we're going to work on the trig functions today. So, when you have something like this, remember the angle on the trig functions is considered an inside. And just like yesterday, if you have an inside, in order for you to do the antiderivative, you have to have the derivative of the inside, which is u prime, next to the du, and then you integrate it to its antiderivative. So in other words, what would have cosine as its derivative would go to sine. Alright, so let's just start with some examples so you can get the hang of it. Let's do the integral of cosine 8x dx. So see this as your inside, and you can be doing all of this in your head. So the derivative of 8x is 8. So I have to have an 8 next to the dx, which means I have to multiply by 1/8 out in front to keep it balanced. I'll hit it with a 1. And now that 1/8 carries along. And then I ask myself, what has cosine as its derivative? Well, that's sine. And you never change the angle. And then remember your plus c. So if I was to do the derivative of this, I would get that back. Let's try another one. Okay, integral of cosecant squared 3x dx. Well, first, is there a function that has cosecant squared as its derivative? And if you look on your sheet, that would be cotangent, but there is an inside to take care of. So again, do it in your head, write it down off to the side, your choice, but the inside is the 3x. So the derivative is 3, so that tells you need a 3 next to the dx before you can get going on this, which means a 1/3 out in front. And now it's ready to go. So the 1/3 carries along. What has cosecant squared as its derivative? Well, if you look on your sheet, cotangent has negative cosecant squared as its derivative, and because there's no negative there, that tells me I needed one here to cancel it out with a plus c. So cotangent's derivative, negative cosecant squared, it's missing there, so I need it here. Okay, let's step it up a notch. The integral of cosine cubed x times sine x dx. Okay, I like to see this as cosine x cubed. Now I got an idea what my inside is, times sine x dx. Okay, this time I've got really a double inside because I got this whole thing inside, and then the angle is an inside. So my u, and I'm looking at doing a power rule here for my antiderivative, is cosine x. So in order for me to do the power rule where I add 1 and times by reciprocal, I have to have the derivative of the inside attached to the dx. So my inside is cosine x. My u prime is derivative of cosine is negative sine x dx. So I need a negative sine x. Well, here's the sine x. I can just attach it over. The only thing missing is the negative, so I can times by a negative 1. As long as I times by a negative 1 out in front. Hit it with a 1. So now remember, now that that's slid over next to the dx, anything attached to the dx gets thrown away, and I'm doing my power rule. So the negative 1 carries along as a multiplier. I'm going to have cosine to the 4th and then times the reciprocal, 1/4. So simplifying it, I'll have negative 1/4 cosine to the 4th x plus c. Okay. Number 4. Same idea. Yeah. Integral of sine to the 5th x cosine x dx. So again, find your inside. I see this as sine x to the 5th. And there's no need for you to rewrite this if you can see it in your head right here. And there's no need to do this stuff off to the side if you can see it in your head. But see the inside as sine x. So what I need next to the dx before I can do my power rule is the derivative of this. Derivative of sine is cosine. Okay, there is a cosine in the problem that was given to me that I'm going to slide over, so I attach it over here. There's no multipliers or hit it with a 1 needed, so now it's ready to go with the power rule. So that's going to be gone with that, and then my power rule here on the 5. So I will have sine x to the 6th times 1/6 plus c. I can fit one more here. Number 5. The integral of secant 2x tangent 2x dx. Well, if you look at your derivative sheet, is there something that has secant times tangent as its derivative? Well, if you check it out, I don't have mine here. Oh, I do. Secant times tangent as its derivative is secant. So the antiderivative of this goes back to secant. So, but I do have an inside. So the angle is my inside. So the u is 2x. So du is 2 dx. So I need a 2 next to the dx. So I need a 2 here, which will get thrown away. The 1/2 will carry along as a multiplier. So the 1/2 stays. And then what gives me secant times tangent as its derivative was secant. And we never changed the angle. Plus c. Okay, can I get rid of, yes, I can. Nobody's here to say no. Okay, number 6. Antiderivative 5 sine to the 4th 3x cosine 3x dx. So again, here's my power, so here's my inside. I'll take the time to rewrite it. Cosine 3x dx. So I'm going to focus on the inside. Make sure I've got the derivative of this before I do my power rule. So I'll let u equal the inside of sine 3x. So the u prime is the derivative of sine goes to cosine 3x times by the derivative of the angle and then the dx. So I need a 3 and a cosine 3x next to the dx. Well, here's the cosine. Got it. I'm going to attach it over there and throw it away. I need the 3 yet. I'm allowed to multiply by numbers, not x's. So 3 goes there, 1/3 here. So the 1/3 and the 5 are multipliers. That's going to carry along. So see that as 5/1. So that'll be 5/3 Now I'm going to do power rule here, times sine 3x to the 5th. Reciprocal of that is 1/5 plus c. My 5's will cancel, and I get a final simplified answer of 1/3 sine to the 5th 3x plus c. And you can leave with parentheses or put it here, it doesn't matter to me. Okay, last one. Obviously there's going to be a catch in this one. Antiderivative of 2x squared plus 1 cubed. So it looks like an inside-outside power rule. So again, I need the derivative of the inside attached to the dx. Well, if my inside is 2x squared plus 1, I can see the derivative would be 4x. That needs to be next to the dx. I don't have an x to slide over. It wasn't given to me in the problem. So I cannot use the power rule here. So what does that mean? Well, there is a way, if I expand this out to all the separate terms, then I can do each term individually. So this could have been easy if there was another x given to us, but there wasn't, so we have to expand this with Pascal's triangle. So we're going to be doing the integral of, and remember when it's to the 3rd power, there will be 4 terms. And your multipliers for that row are 1, 3, 3, 1. And then you take 2x squared, and you've got to cube that. 2x squared, and you square that. 2x squared to the 1st, and then to the 0, and then we take the positive 1. Well, 1 cubed times 1 squared times 1 to the 1st, not that those are needed. So, if I simplify here, I'm going to have 2 cubed is 8. Multiply when you've got power to a power. Plus, let's see, this will be 4 times the 3 is 12. Will be x to the 4th. Now this is to the 1st, so I'll just have 3 times 2 times 1, so a 6x squared, and then a 1. So I've got all of that times the dx. So, when it's to the 1st power out here, just like you had problems yesterday, it's each term separately. So if that's all I had was this term, I just do my power rule shortcut where I add 1 and times by reciprocal. So the integral of 8x to the 6th would be 8x to the 7th times 1/7. I put it over 7. This one will be 12x to the 5th times 1/5. The 5 down there. This one will be 6x cubed times 1/3. Puts the 3 underneath. That's got to simplify. This one goes to x, because the derivative of x is 1, and a plus c. So the only thing left would be to change this one to 2x cubed. Everything else is going to stay the same. Okay, and then the homework appears to be page 193. Let me double check. Calc 13 to 16, 23 to 28, and 33 to 43.